All right, hi chemistry students. We're going to talk today about endothermic and exothermic reactions. These classifications apply to phase changes and also to chemical reactions. So if you need to put this on pause, go ahead and find the appropriate page in your packet that says phase changes and endothermic or exothermic reactions at the top. All right, so as you know, there are three main phases that we are discussing in this class, solid, liquid, and gas, and I've already drawn out the molecules and what they would look like in each phase. And so in my first box, I have molecules of a solid. Notice that they are packed very closely together and they don't contain any like zoomy lines showing that they're moving. It's not that they're frozen in place, it's just that they don't have a lot of energy and so they're not moving around very much, and they stay nice and closely packed together. In a liquid, however, you can see that the molecules are spaced apart more and they have these little zoom zooms, zoom zooms, and so they're moving around a little bit faster. And then with a gas, they are moving around the fastest, so they've got three little zoomies on each molecule. And they're zooming around, moving around really quickly. They're spread out, and because I don't have a lid on my container, they've even escaped the walls of my container. And so that's what we have for a gas. Now, I just wanted to mention that when we're talking about reactions and things, molecules have to collide in order to create a chemical reaction. So the faster that they go, the harder the collision is going to be. And for some reactions to actually take place, you need collisions that require a lot of energy, whereas others really don't. So we're going to talk about that just a little bit in the next pages that we talk about. Okay, so let's take a look at some of the questions that we have down here, and let's use a text box. There we go. Okay, so our first question is, what is temperature? Well, temperature is simply a measure of the average kinetic energy. And remember, kinetic energy is the energy of motion of molecules in a substance. So that's what temperature is. So when you have a high temperature, it means that the molecules are moving around a lot. And if you have a low temperature, it means that the molecules are moving around very little. So in which phase, my solid, liquid, or gas, do the molecules have the most kinetic energy? Well, that would be in the gas because they've got the three zoomies on each molecule. And my solid is going to have the least. Okay, so number 4, it's asking about changing a solid to a liquid. And do we need to increase or decrease molecular motion? Well, let's look back at our picture. In order for us to change a solid into a liquid, to go from here to here, am I adding zoomies or am I taking them away? My solid molecules have none, while my liquid molecules have 2 on each one. So that means I'm increasing the number of zoomies, so I'm increasing their kinetic energy. And so in order to change from a solid to a liquid, I have to increase the energy. So I've got an increase in energy, which means that I am increasing molecular motion. So I'm increasing motion. To move from a solid to a liquid means that I'm melting it. So this is called melting. There we go. And so let's answer our questions back down here. So to change a liquid to a solid, which is called melting, the fancy term for this actually is called the heat of fusion. And do we need to increase or decrease molecular motion? Well, I think I just showed you we need to increase it. And how can we do this? We need to add energy to the solid molecules. And how can we do this? We can add heat, we can agitate it or stir it. So those are just ways that we can add some energy to our molecules. Okay, number 5 says to change a liquid to a gas, what is it called? And, the same questions, do we need to increase or decrease the amount of energy? Well, again, I'm going to use the same color here. So to go from a liquid to a gas, I have increased the number of zoomies, right? My liquid molecules each have 2 zoomies, while each of my gas molecules have 3. So I have to increase the energy, and I have to increase the motion. Changing from a liquid to a gas is called evaporation. All right. So here we go. Text box. So to change a liquid to a gas is called evaporation. And if you want to be fancy, you can call it the heat of evaporation. And do we need to increase or decrease molecular motion? Well, we need to increase it, so that our molecules are going to move around more in that liquid, and eventually they're going to be so energetic that they're just going to rise out of the liquid because now they're a gas. And so then the molecules are going to have so much energy, they're going to want to spread out and leave that container if you don't have a lid on it. Okay, number 6 says that because you are adding energy to the molecules, the scenarios in number 4 and 5 are considered endothermic. So you're probably like, well, what does that mean? What this means is that the molecules that are the reactants are absorbing energy so that they can move around faster. And then they change phases. Then they change from a solid to a liquid, and then from a liquid to a gas. So in our scenarios that we have up here, we're going to draw a new line. So to go from a solid to a liquid, this is endothermic. And the molecules are going to absorb energy, which I am abbreviating with a capital E. Once again, to change from a liquid to a gas, this is also endothermic because my molecules have to absorb more energy again in order to move around faster and to come out of the solution as a vapor or as a gas. Now, at this time, I just wanted to make a little note. When you're looking at chemical reactions, the molecules, the reactants themselves, they are called the system. So I'm going to write that up here in the corner. So my molecules are the system, while the environment around the molecules is called the surroundings. So the environment is called the surroundings. So my molecules in my little pictures here, my blue molecules, these are the system. So, and then like the beaker, like the outside of the beaker over here, those would be the surroundings. And so where are my molecules for the solid obtaining the energy to move around faster to become a liquid? From the surroundings. And so this is why if you have ice inside of a glass and you touch the outside of the glass, it feels cold because the ice cubes that are inside of the glass are taking the heat from the surrounding air, and the molecules are absorbing that energy and moving around faster and melting the ice to form water. And if you leave that glass out long enough, the water is going to continue to absorb energy from the surroundings. And if you leave it out long enough, it's all going to evaporate. And that's where our liquid water has turned into water vapor or gas. And so if you flip down to the next page, what I was just explaining is exactly what this little paragraph is talking about. So the reaction or the molecules are called the system, while the environment is called the surroundings. So let's take a look in the opposite direction. So number 7 says to change a gas to a liquid, and this is called condensation. So why don't I just write that here since we're here? Condensation. What do you need to increase or decrease molecular motion? Well, now we're moving from a gas to a liquid. So the gas has, if we look back up here, the gas has 3 zoomies on each molecule, and my liquid only has 2. So to go in the opposite direction from a gas to a liquid, we have to decrease the energy so we can decrease motion of our molecules, and this is called condensation. And remember that if we're decreasing the motion of our molecules, that means that we are decreasing the temperature. So here we need to decrease molecular motion. And how can you do this? The molecules need to release their energy. So the gas molecules have to release energy to the surroundings. And this can be done by cooling it down. Number 8, to change a liquid into a solid, do we need to decrease or increase molecular motion? Well, once again, my liquid is becoming a solid. We have to decrease energy and decrease motion. This is a process called freezing. And so once again, our molecules are going to need to release energy to the surroundings. So our liquid molecules have to let go of some energy and release it to the surroundings. So this is called freezing. We need to decrease molecular motion. And my answer from the previous question on how we do this is the same. The type of reaction that we have here is called exothermic. And the reason why is because energy has to exit the system and enter the surroundings. So it's exiting, exothermic. Energy is exiting the molecules themselves. And so let me grab my pen here. All right, and so here, to go from a gas to a liquid, this is exothermic. And our molecules are going to release energy. And the same for the other side. This also is exothermic. And our molecules have to release energy, again, to the surroundings. All right, that's it for video 1. Get ready to tee up video 2.